which is on section 13.2. It's recording. Okay, guys. Today, in real sense, I'm not going to start the finding limits in 3D, because if you want to find it, if you want to find the limit for function of two variables, two or more variables, then you have to understand, you have to recall the limits of function of single variable. Okay? Class, are you ready?
Yes, miss.
Well, even if I don't know if you remember, I don't know if you remember the theorem. If y equals to, we have seen this in calculus 1, you will be able to recall if you have seen this before, of course. If this is a polynomial, if this is a polynomial, then the limit x approaches c, p of x, sorry, that equals to p of c. Have you seen this before?
Yes, miss. Definition of limit.
Yes, ma'am.
No, this is not definition of limit. This is definitely not the definition of limit. Definition of limit is even difficult. Not, I shouldn't say difficult, I should say abstract. I should say abstract. It says that polynomial is such a function. Polynomial is such a function which is continuous everywhere. And continuity says that a function is continuous at some point where the limit and the function values are equal. And since polynomial is continuous everywhere, that means polynomial is continuous at c as well. So definitely the limit at c and value at c must be equal. So though it says that limit is actually the value of the function, but when you talk about the limit, when you think about the limits, the first thing that should come to your mind is that limit means approximation. Even though you can take it as equal to some number, but you have to believe that when you call it a limit, that means you are working with the approximation. You are not getting the exact value. If you can just digest this, then limit concept will be easy for you. Okay? For example, this one. I have taken a polynomial of degree 1. I have taken a polynomial of degree 1. So if I take the limit, then I just need to plug in 1 in the function, because if this is the polynomial, so limit must be the value. So I'm plugging 1 in x, and then I have 1 plus 1, which is 2. But remember, when you are talking about limit, you believe that x is close to 1 but not equal to 1. X is close to 1 but not equal to 1. But when you are evaluating, you are taking x equal to 1. So this is approximately, we know that the limit is approximately 2 because x is approximately 1. So this is an approximation. That's the main thing that you need to understand when you study limit. Did you get my point?
Yes, ma'am.
Yes, miss.
So let's read the definition that you have seen in calculus 1 already. So this is limit in 2D. So limit, it says that this is written exactly in words that you have seen in your book. If the values of y, read the definition carefully. Just read it carefully. If the values of y, which is given by f of x, or function of x, so if the values of y, which is function of x, that means when we say that limit, that means we get the approximate value of y. I repeat, when we call that limit of a function f of x, that means, using usual notation, that means we are talking about approximate value of y. So if the values of y, which is f of x, can be made as close as we like to the number L, by taking values of x sufficiently close to a but not equal to a, then we write the if these values, that means the if x is close to a, then if value of f of x is close to L, then the whole thing can be denoted by this the small notation which says that the limit of f is L as x approaches a. This is how we did it. So the limit of f as x approaches a is L. Okay. So, for example, better example to see the limit, because we exactly see that x cannot be 1 here. Am I loud and clear in class?
Yes, miss.
Yes, miss.
Yes, ma'am.
So look at the rational function now. The domain of the rational function is all real numbers except 1. That means the number 1 is not in the domain. So definitely we do not have an output for the input, which is 1. If I try to evaluate the function at 1, we get 0 over 0. Is it undefined?
Yes, miss.
Do we call it
Indeterminate.
undefined?
Indeterminate.
Indeterminate.
0 by
We
0.
call it indeterminate. This gives us a huge message. It says that the numerator and the denominator, they share a common factor.
Ma'am, 1 by 0 হচ্ছে undefined না?
Yes. Yes. Non-zero by 0 is undefined. Yes. So that this 0 by 0 says that since we have a rational function, so it says that
0
it
by
says
0
that the indeterminate. Yep. So this 0 by 0 says that the numerator and the denominator, they share a common factor, and the common factor is, since x equals to 1 gives us 0, that means x minus 1 is the factor. So factor the numerator, because denominator is linear, we don't have to do anything with the denominator. Factor the numerator and reduce it. So when you reduced, reduction means you are dividing by x minus 1, so definitely x cannot be 1. So when you want to say that this is actually equal or same, then if f of x is this, the same f, then you have to, I repeat for the third time, you have to mention that x doesn't equal to 1. Now if you are to evaluate this limit, that means if you are to evaluate the limit where x approaches 1, okay? X doesn't equal to 1. This is 1 is not in the domain. But if you want to know, since 1 is not in the domain, and I said it before, even in your class, when you have something like that, it means that on the graph of the function, you have a hole. I hope I have something like that. Here you go. This kind of graph you have a straight line with a hole at the point 1, 2. Guys, do you read me?
Yes, miss.
So it's a straight line, because y equals to x plus 1 is a straight line. Y equals to x plus 1 is a straight line. So it's a straight line. Obviously, it's a straight line. But since x equals to 1 is missing from the domain, but if x was 1, then y was 2. That means 1, 2 point must be missing from the graph. So you have a hole at the point 1, 2. So this is an obvious question. Then what should be the possible or approximation of y if you take inputs which is close to 1? Because you have to feel that whatever value which is less than 1 or greater than 1, whatever those values are, if you pick any of them, if you are able to write any of them, still you miss infinitely many of them between that number and 1. Did you get my point?
Yes, ma'am.
Miss, can you repeat?
So give me a number which is just before 1. Just give me the number which is just before 1. The number which is
0.95.
0.95. Can you get even closer to 1?
0.999.
Can you give an even closer to 1?
More 9. I mean 0.
How many more? How many more?
Infinitely.
20.
Just 29. If another student comes and writes another 100 nines, it is even closer to
Infinity.
1, but not 1. Infinity. And how many nines make it infinite? Make infinitely many nines? Do you have any idea?
Infinitely many nines make
Yeah.
infinitely
How many of them make infinitely many? Do you have any idea?
Countless.
It's an abstract concept. Countless. Then another question comes. So, I mean, you can continue using similar words, but it doesn't explain anything to you, right? So the understanding is that doesn't matter how close you go to 1, still you have infinitely many opportunities to go even closer. That means how close if you write a number, doesn't matter how close that number is to 1, still you have infinitely many numbers between that number and 1. So this is when you are trying to know some value, then this is an obvious a question that what will be the scenario then if x is really close to 1? What should be the obvious? That should be the obvious question. Then what should be your understanding? That is the limit concept. Okay, that is the limit concept. Okay, and since we understand that. Since we understand that 0.999 doesn't matter how many nines you pick, since this gives us the approximately 1, similarly, if I write 1.0000, doesn't matter how many zeros I'm going to write, then at the end I'm going to put a 1. So 1.000, infinitely many zeros, then 1. And this number is greater than 1, but close to 1, but not equal to 1. Do you get my point?
Miss, can you repeat again?
Give me a number. Give me a number up to your capability that is really close to 1, which is greater than 1.
1 point infinitely many zeros, then 1.
That's what I said. But that number is not 1, right? That number is greater than 1, but not 1. But both numbers, if you put 0.999 infinitely many nines, that number is close to 1, but not 1. That means approximately 1, but is smaller than 1. And 1.000 infinitely many zeros than 1. That number is larger than 1, close to 1, but larger than 1, approximately 1. So limit concept says that if we want to know, if you want to say that the limit exists, then the smaller one, the smaller approximation is called the left limit. The larger approximation is called the values of x. I'm talking about the values of input. I'm not talking about the values of output. Okay. So when the input approaches the required point from the left by getting bigger and closer, this is called the left limit. And when the input gets closer to the point, the desirable point, by getting smaller and closer, that is called the right limit. So when those two limits are equal, then we say that the limit exists. For example, when you have this example in your hand, x doesn't equal to 1. So pick few values where x is close to 1 but is smaller than 1. Pick few values which are close to 1 but larger than 1. And see the approximation from left. Left means these numbers, all these numbers which are smaller are sitting on the left, and the numbers which are larger, those numbers are sitting on the right to 1. So this is called the left approximation, and this is called the right approximation. And in our understanding, we approximate both of them by 2, right? 1.99999 is approximately 2. 2.000001 is approximately 2. Since the approximation from left side and the approximation from right side are equal, we say that the limit exists. Do you understand that?
Miss, so at a point of 1 comma 2, there is a jump of the function, right?
There's a jump of the function. There is a, yep. But they're shaking hand with a hole. I mean, look at the piece of the curve. This is the left piece of the graph, and this is the right piece of the graph, and they are coming together at the same point, but they are not joining the point. Do you understand that? That means they are shaking hand with a gap.
Yes, miss.
So limit
0 by
exists.
0 লিখা কেন?
0 by 0, because if you take x equals to 1, then you have 0 by 0. You have seen that before, right? Here you go. F of 1 is 0 by 0, indeterminate. That means you cannot take 1 in the domain. That's what it means. Okay, so if I now summarize all this understanding, so look at the functions over here. Say by saying that they're shaking hands, this point we can say that they're shaking hands with a gap. So the shaking hand means the left portion of the curve and the right portion of the curve, they approach to the same point, but they don't fill the gap. So the limit exists here. Limit doesn't exist here because it's not the shaking point. That means the left portion comes to the y value where y is -1, and right portion comes to the point where the y value is +1. That means from the left side, y values are approximating because y doesn't equal to -1 for this point. For this point, y doesn't equal to -1. But if we take the inputs for these points to continue this, to make this a continuous line, you have infinitely x values on this portion of the graph. So if you pick those x values, then y values are approaching to -1, but it doesn't take the value -1. On the other side, from right side, if you take the x values which are close to, which are on this point, x values on these points, they're getting closer, but y value is not exactly 1. If for this graph, if x is 1, then y value is 2. But if x is smaller than 1 but close to 1, look at, this is a very good example, class. This is a very good example. This solid ball says that this point is a portion of the graph, and this point is 1, 2. That means if you want to evaluate the function at x equals to 1, then you get y value, which is 2. F of 1 equals to 2. But if you have 1 really close to 1 but less than 1, and you know this is an abstract concept, because we will be able to keep moving closer to 1, but we will not be able to reach 1, never ever, right? So doesn't matter how close you get to 1, but if the value is smaller than 1, then y value is close to -1. If the value is close to 1 but larger than 1, then y value is close to 1. So approximation from the left is -1, approximation from the right is 1. Since they are not equal, limit does not exist here. Do you understand that portion? Oh, I'm sorry. Here y value is 0 because this is on the x-axis. So here is -1, here it is 1, and here it is 0. This is on the x-axis, class. You didn't correct me. Did you understand my explanation? Because I was saying it wrong, but no one corrected me. Why was that so? Am I in class?
Yes, miss.
Did you understand what I said so far about this curve? The observation of the graph around 1? Class?
Miss, মোটামুটি বুঝছি, miss.
Okay then. So at this point, from the left, y values approaches 2. From the right also, y values approaches 2. So limit exists. Limit does not exist in this position. Limit does not exist in this position. That means a limit as x approaches 3. Y doesn't have a fixed, a unique approximation. So limit doesn't exist. Approximation doesn't exist because from left, from right, we have different approximation. Okay.
Miss,
So, yep.
Scalar dotটার এটা কি?
Colored dot means it's a portion of the graph. For example, over there, this is the point which is 3, 0. This is the point on the x-axis, 3, 0. This solid ball says that this point is portion of the graph, and it says that 3 is in the domain. Okay, and this is also a point which is 3, 1. This is a point which is 3, 1, but this point is not on the graph. This point is not on the graph. Similarly, this point is a portion on the graph, but these 2 points are not. 1, 0, 1, -1, they are not portion of the graph. Open ball means excluded, solid ball means included. Yep.
Miss, so limit doesn't exist at 1 from the left hand side, and limit doesn't exist at 3 from the right hand side, right?
No. Who said that limit does not exist from the left side? Because from the left side, can you please just give me the value of this missing point, value of y at that missing point? I'm talking about this one. What is the value of y? -1. And graph is close to that point, right? Graph is only missing that point. Otherwise, the graph goes close to that point. Just missing one single point. That means y is approximate value of y is -1. You are missing the point that limit means approximation. See, I said that this point is not portion of the graph. It doesn't have to be portion of the graph to take the limit, because limit is not the exact value. Limit is the approximation. I said it. If you are not able to digest that, limit will be a difficult concept to you. This point doesn't need to be a portion of the graph to have the limit. Left limit, if you get close to x values, which are smaller values but close to 1, then y values are on this portion of the graph. So if you get closer to 1, then y values get closer to -1. So limit from left is -1, and the limit from right is 0. Because this point is 1, 0, which is missing, but the graph continues till that point, except that point. That means values are close to 0, y values are close to 0, close to means approximately 0, that means right limit is 0. Since those two limits are different, so limit doesn't exist. So here
3 to 4 এর লাইনটা বুঝিনি।
3 to 4, what do you mean by 3 to 4?
সো যে গ্রাফটার মধ্যে একদম লাস্টে 3 থেকে 4 এর যে উপরের লাইনটা এই
This is a horizontal line. This is a horizontal line. That means if x is greater than 3, that means if x is greater than 3, y is always 1. Doesn't matter what is x value. If x is greater than 3, yeah, it's strictly greater than 3, then y value is 1. If x is 3, then y value is 0. If x is between greater than 1 and less equals to 3, then you have a portion looks like a parabola opening downward. It's a horizontal line, no? If x is greater than 3, then y is 1. Definitely, since we are trying to understand limit, this is a piecewise defined function. So I will leave it here today because I have just 7 minutes, and then we will just conclude with the thing that did I write it down somewhere that the limit exists? Definitely I should. Definitely I have. But where? Seriously, I didn't. Okay, here you go. If the limit, guys, if the limits from the left and from the right are same, then the limit exists, and the value of the limit is the common limit. Okay, that means limit doesn't exist if from left side and from right side the both limits are not same. Okay, now the question is that if we have the function, class, do you read me? Are you with me?
Yes, miss.
If we have the function which is a function of single variable, that means y equals to f of x. What is the dimension of the domain? Y equals to f of x. What is the dimension of the domain?
Miss, only R.
Only R, one dimensional. A straight line has dimension 1, right?
Yes, miss.
Now the question is, when you have a straight line and you have a point on that line, you have a straight line and you have a point on that line, and if I say that approach that point being on the domain, approach that point without leaving the domain, that means approach that point walking on this line. That is what it means, right? So you have to
Yes, miss.
you have to approach that point walking along the line. If you don't want to leave the domain, then you have to walk on the line. So then the approximation, there are two different approximation. You can approach the point from the left, or you can approach the point from the right, since you are walking on some real number line. Since we have taken it as a horizontal line, so you have only left side and right side. So that means you have only left limit and right limit. And we know that if left limit and right limit are equal, only then the limit exists. Did you understand this statement?
Yes, ma'am.
Yes, miss.
Okay, very good. Now let's generalize the statement. Now I'm saying that the limit exists. Guys, listen to me very carefully, because with this statement, I will end the lecture today. The limit exists if the limit from any direction, if the limit is same from any direction. If the limit is same, or if the limit is equal, from same means equal, if the limit is same from any direction, any possible direction. By the way, y equals to f of x. How many directions do we have?
2.
Left and right. So
Yes,
for
miss.
y equals to f of x, our statement was the limit exists if the left limit equals the right limit. Left limit, right limit, they are same, limit exists. That much you already know from calculus 1, right?
Yes, miss.
Very good. Now guys, on the floor of your room, let's say that on your floor, I place a ball on the floor. And I'm asking you, so now I'm asking you to approach the ball from any direction possible. How many directions do you have?
2 direction.
4.
Are you sure? I want to take a zigzag line. I want to take a straight line. Are you sure there are 2 directions?
3, ma'am. 3.
Are you sure 2
directions.
directions?
4 directions.
ম্যাম রুমের মধ্যে কি এটা কি ম্যাম থার্ড ডিমেনশনে কল্পনা করব নাকি সেকেন্ড ডিমেনশনে?
It's a floor. Floor is 2-dimensional. But a ball is on your floor. How many directions do you have to approach
Infinitely
that
many
ball?
direction.
Infinitely many directions.
2, 3 becomes infinitely many now. But do you understand that it is in actual sense, there are infinitely many directions? Do you understand that?
Yes, ma'am.
See, I have drawn only few. So that means when we study functions of 2 or more variables, that means function of 2 inputs or function of more than 2 inputs. Let's say that function of 2 inputs, domain is 2-dimensional. So any point on the domain, if we want to approach that point, we have infinitely many directions, and limit exists if the limit is same from each and every direction. So the question is, when you studied calculus 1, you had only 2 directions and you were scared of evaluating limit. Now you have infinitely many directions. How many minutes do you need to do that?
Infinitely many minutes.
Infinitely many. Exactly. So that means if I want to say that the limit exists, That means if I want to claim that from any direction the limit is same, I have to be tricky. I cannot evaluate limit from each and every direction. It is impossible because we have infinitely many directions. So we need to apply some trick. But if I want to say that limit does not exist, then I can just show two different directions where we have different limits, and that's it. We can say that from this direction and that direction, limits are not same, so limit does not exist. Do you understand my point?
Yes, ma'am.
Yes.
And from there, I will continue in next lecture. Okay? So that's it for today. So don't forget where I'm stopping here. Okay? So I will continue from here. So
Miss attendance even no?
Not care attendance nibona. So class, this is very important for you to read or think about the literature or about the concepts or trick that I have discussed today. Please listen to the recording couple of times. If listening to it once doesn't help you enough to understand the abstract concept, it is very abstract concept to understand the limit. Okay, so see, this is a different type of definition. I mean, same thing, but presented in different way. This is limit in 2D. Then we will continue from there to 3D. Okay, that means from function of single variable, we'll continue to function of two variables from there. So this is going to be lecture 5 for us. Okay? So whatever I said about the limit today, it wasn't part of Math 250. Everything was part of Math 120. But it seems like I don't know, you haven't given enough of your attention when you studied 120, when you studied limit at least, because I could see it from your responses that you need to understand limit in better way, right?
Yes.
So we left the class with understanding that for the function of two variables, the domain is two-dimensional, right? For the function of two variables, domain is two-dimensional, and there are infinitely many directions to approach a point, right?
Yes, miss.
Then we left. And we will say that the limit exists if the limit is same from each and every direction. So now let's see the formal definition. Let's see the formal definition. In this picture, this is the picture of the domain, and this is the picture of the range. That means 2 dimension, 1 dimension, both together 3 dimensions. So domain, the function of two variables, that means domain is 2 dimensional. Since we have a output which is a real number, so 1 dimensional. So these two together 3 dimensional. So a limit is if you want to approach a point, then you draw a disk around that point. Okay. So if you take the radius of the disk close to 0, then you are covering all the infinitely many directions, because no direction can approach the point without crossing the circle, which is the boundary of the disk. So see, whatever the direction is that goes through this disk. So if you draw a disk around a point which you want to approach, then if you take the radius of the disk close to 0, then you are covering all infinitely many directions. And we will say that limit of the function f, which is a function of two variables x, y, as x approaches a point AB, which is the center of the disk, The limit is L if and only if for any point inside this tiny disk, very small disk, for any point from that disk, the output, the value of the output will remain inside some epsilon interval. Epsilon interval means that the length of the interval is very small. So if you think of a disk, of one-dimensional disk is an open interval. One-dimensional disk is an interval. So if the center of the disk is L, then for any point from that disk, any input from that disk, output will be in that interval. Then we will say that the approximate value of Z is L as the approximate input. That means if the input XY is close to the point AB. And since we have considered a disk, that means we have considered all infinitely many directions. Another picture, when you see it in 2D, this is the picture. See, here we have said the epsilon neighborhood, or one-dimensional epsilon neighborhood, or epsilon interval, however you call it. So that you have a disk on the domain with the center at the point AB, and the radius of the disk is delta. If delta is close to 0, then for any point from that disk, the output must be close to that L. Okay, close to that L. Then we will say that limit of the function is L as XY approaches AB. Now let's see the formal definition. Let's put the pictures together on the same line. Good enough, right? Okay. So now the formal definition is class. Can you hear me?
Yes, miss.
Yes, ma'am.
Miss.
Definition. Let f be a function of two variables, and assume that f is defined at all points of some open disk centered at the point AB, except possibly at AB. We don't have to have the function defined, which is defined at the center of the disk. Not necessarily. A function defined or not, limit doesn't depend on the value of the function. Okay. So we write that the limit of the function is L as XY approaches the center AB of the disk AB, if for every epsilon greater than 0, we can find delta greater than 0, such that means as close as we take, as close as we want these two values be. As close, epsilon is our chosen epsilon, so that a value of f and L are close in epsilon distance. The value of f and L is in epsilon distance. This epsilon is chosen by us. If we can make them in epsilon distance, then by finding a delta, which will be radius of the disk, so that every point xy will be in that disk. That means, what does it mean? For every epsilon greater than 0, if we can find del greater than 0, such that whenever the distance between the input and the center of the disk is less than delta, that means whenever the input is in the disk around the point AB, then the value of the function is in epsilon distance in the interval in the one-dimensional disk with the center L. That means the value of the output and the L, the difference of them must be less than epsilon. That means in generally we mean that whenever they are close to each other, then these two numbers will be close to each other. Okay, so this is the concept of the limits. So now Class, are you with me?
Yes, ma'am.
Yes,
Yes,
Okay,
ma'am.
so now these are the generalization of the limits. If the limit is L as xy approaches AB, if the limit is L as xy approaches AB, then limit will be L for each direction. Limit will be L for each direction. Otherwise, limit doesn't exist. That is what it is said in the first line. If the limit is L as xy approaches AB, then the limit will be L for all the direction. Limit will be L as xy approaches AB along any smooth curve. Along any smooth curve, by along any smooth curve, each curve denotes a direction. Is this good to you? Do you have question?
Miss, can you repeat?
We mentioned about the infinitely many directions, and we agreed that limit will exist if the limit is same for every approach. That means the limit will be same for each direction. And those direction now, direction is this. See, we didn't say left direction, right direction, even for calculus 1. We said left limit, right limit. So we should have a nice mathematical way to call it, right? Now, each direction is called by some smooth curve. So along any smooth curve means, in place of a smooth curve, you can think of a direction to approach the point. So along any direction. So if the limit is L, then limit will be L, limit will be same. Limit will be self along any direction. That means along any smooth curve. Is it clear now?
মিস along smooth curve এটা বুঝছি মিস, কিন্তু ওই যে বলেন না যে লিমিট আর এটা সেম, এই জায়গাটা বুঝতেছেন।
Look at this thing. Once limit is L, the limit is always L. That is what it is said here. If the limit of f is L as xy approaches AB, then limit of f is L as xy approaches AB along any smooth curve. What does it mean? If the limit is L, then it must be L along any direction. Okay? Is this good now?
Yes, miss.
If limit fails to exist along some smooth curve, that means if the limit is undefined along some smooth curve, or if limit has different values along two different smooth curves, then the limit does not exist. So in our words, if limit is L, then limit will be L from each direction. If one direction doesn't have limit, if limit is undefined along one direction, or if limits are different from two different directions, then limit does not exist. Are you good?
Yes, miss.
Do you have question, class? Okay. Now let's try to understand this notation. Limit means approximation but not equal. So when I say that xy approaches 0, 0, that means the point xy is close to 0 but not equal to 0, but not the same point. This is the concept of limit. We understand that, right? Plus?
Yes, miss.
And that means if xy is close to 0, 0, then x and y are not simultaneously 0, because xy close to 0, 0, not the same point. If xy are simultaneously 0, then you get the origin, because since we have xy close to 0, 0, not necessarily they are the point is, definitely the point is not the origin, then definitely they are not simultaneously 0. If x is 0, then y must be non-zero. If y is 0, x must be non-zero. There are scenarios where x and y both are non-zero but close to 0, 0. Are you good?
Yes, miss.
মিস এটা বুঝি নাই মিস।
This implies this. Okay, and
Okay.
since x and y, x0 and y0 is not possible, either x0 or y0 or none of them is 0. Okay, x is close to 0, y is close to 0. X is close to 0, y is close to 0. If xy close to 0, 0, then x is close to 0 and y is close to 0. That is good. But y is close to 0 does not mean that y equals to 0. X is close to 0 does not mean that x equals to 0. But xy close to 0 can be, xy close to 0, this can be written in that way. This can be this. This can be this along the y-axis. Along the y-axis. This can be this along the x-axis. Or otherwise.
মানে মিস একটা জিরো হতে পারবে।
একটা 0 হতে পারবে। On the x-axis, y is 0. On the y-axis, x is 0. But they are not simultaneously 0. Okay? None of them can be 0 as well. None of them can be 0 as well. If take a point which is neither on the x-axis nor on the y-axis, then x, y both are non-zero. But still the point can be close to origin. Did you understand? Very good.
Yes.
Yes.
Okay then. So do I have to explain you this?
No miss.
What about this one?
Positive 2.
+2.
Okay, very good. Very good. So now I will state a few things. Let's see if you understand that. Suppose that we are given a question and we are asked to show that the limit does not exist. Show that the limit does not exist. Do you think that it will be enough to find two different directions, in which directions we will get different limits? Is it enough to claim that limit does not exist?
Yes, miss.
Yes.
Class? Isn't it enough?
Yes.
Okay. Now, let's say that the question is, find the limit or show that limit exists. Find the limit, either the question is find the limit or show that the limit exists. Can we check 10 directions, and if I have same limits along 10 directions, then I can claim that limit exists? Is it true? How many directions do we have total?
Infinite.
So from infinitely many directions, we have infinitely many directions, and from each direction we must have same limit. So checking only 10 directions does not confirm the limit, does not confirm the existence of limits, right?
Yes, miss.
Yes, miss.
Is that good to everyone? Okay, so now let's try to understand. Now we said that a direction can be considered as a smooth curve, didn't we? We said that so far we have understood as the directions. Now each direction will be given by a path, by a line. Each direction will be given by a curve, and those curves we can consider them as a smooth curve. Okay, so now let's say that if xy approaches AB and y equals to f of x is a smooth curve, then x approaches A implies y approaches f of A, which is B. Do you understand that?
Yes, miss.
Class, are you good?
Yes, miss.
Yes, ma'am.
Yes, miss.
Yes.
That goes through the point AB. Where am I? Then, now even clear, right? Even more clear. Even more clear. This function, this is a smooth curve that goes through the point AB. Now, if x approaches A, actually, I don't think it's necessary. Okay, yeah, better. If x approaches A, then the x approaches A implies y approaches B. Note that we have chosen y equals to f of x so that AB is on the graph of y. Oh, okay, it was there. Do you understand this? Class?
Yes, miss.
So now, as we agreed, for example, show that the limit does not exist. Show that the limit does not exist. So it will be enough for us to find carefully, we need to find two directions or two smooth curves, two equations that goes through the origin, because xy approaches origin, that goes through the origin, two curves that go through the origin, so that along those curves, this limit must be different to say no. Are you good?
Yes.
So now remember now, direction means path means curve means equations. Okay, so let's start the solution. Okay, so here you go. This is what we have to prove, that this limit does not exist. Now, since we are approaching the point 0, 0, so we need to think of curves that goes through the point 0, 0. Remember, these are few examples. Y equals to x, y equals to minus x, y equals to mx, y equals to minus mx. M can be non-zero. Definitely, m can be non-zero. It works even m is 0, because y equals to 0 means the x-axis, x equals to 0 means y-axis. Those two, x-axis and y-axis, goes through the origin, right? Y equals to x squared. This is the parabola, touches the origin. The vertex is the origin. This is a power function. This is also touches the origin. Okay. Sine function also goes through the origin. There are infinitely many of them. So you can choose two that gives you different limits. Okay. So let's try to make it constant. Easy way. So how can I choose it? Let's say we have chosen x-axis. By the way, along the x-axis, if I say along the x-axis, I have to take the class. Can you hear me? And am I loud and clear?
Yes, miss.
Okay. So when you say the direction is along the x-axis. So when you call the direction will be given by some equation. So when you say that along the x-axis, that means we say that along the line which is given by the equation y equals to 0, because y equals to 0 is the equation of x-axis. Now, since xy approaches 0, 0 and y equals to 0 is the equation, this is the equation that goes through the point 0, 0. If I combine these two, then xy becomes x comma 0 because y is equal to 0. So x comma 0, use the equation to change it from two variables to single variable. Remember, you have studied calculus 1. You know how to find limit for function of single variable. So your goal is to change it from several variables to a single variable by using equations. When you can do that, you are in your comfort zone. So I have equation where y is 0. So xy is x comma 0. That means it becomes now, you have now a single variable, and this one can be written as x is close to 0 because y is equal to 0. So x is close to 0. X cannot be equal to 0. Do you understand this?
হ্যাঁ মিস, যে তখন বললেন যে একসাথে সিমুলটেনিয়াসলি xy 0 0 হইতে পারবে না।
Exactly. So now along this line x is close to 0. So now in place of this equation, y is equal to 0, x is close to 0. So write down those two things. Y must be replaced by 0 because y equals to 0 and x must be close to 0. So see, y is 0 times x square plus 0 square. So if you do the simplification, x is close to 0, x is not equal to 0. So then you get this. Remember, the denominator is not 0. Since x doesn't equal to 0, x squared doesn't equal to 0. So this is 0. This is 0 because denominator is non-zero. So definitely the fraction is 0. Are you good?
মিস, আমরা যখন আগে লিমিট করতাম তখন তো মিস আমরা একটা ফর্মে নিয়ে যাইতাম না, যেন ওই যে ডেনোমিনেটরে এক্স স্কয়ারটা না থাকে। ফর এক্সাম্পল মিস, তখন তো আমরা ডিরেক্টলি ওই ভ্যালুটাই বসাই দিতাম যেটা লিমিটের ভ্যালু থাকতো।
I don't understand what you mean.
মিস, আমাদের এরকম থাকতো না ফ্র্যাকশনে যে ধরেন 1/x - 2 আর মিস ওখানে লিমিট x টেন্ডস টু 2। তো মিস আমাকে তো ওই ডেনোমিনেটরটা চেঞ্জ করে মানে মিস এমন একটা ফর্মে নিয়ে যেতে হইতো যাতে করে আমি লিমিটটা বসাইতে পারি। ফর এক্সাম্পল লিমিট x টেন্ডস টু 2টা তখন আমি যেন আমি বসাইতে পারি 2, ওরকম একটা ফর্মে নিয়ে যেতাম। তো মিস এখানে তো আমার আনডিফাইন্ড ফর্মে আছে না, নিচে আমি তো লিমিটটা বসাইতে পারতেছি না।
I mean, why do you have to subplug in? Don't you remember that limit of a constant is the constant itself? Don't you remember the property of limits?
মিস আমি এই জায়গাটা যে জিরোর নিচে যে
যেখানে দরকার নাই সেখানে তো চিন্তা করার দরকার নাই বাবা। This is just k because the function is independent of limit. Limit of a constant is the constant itself. Yeah, I understand what you meant. But this is not for everything and every scenarios, right? Each limit has a different scenario, and they have to be managed differently. So here we have limit of a constant. Now we have limit of a constant because whatever x is, since x is not 0, whatever x is, this fraction is just 0. So in actual sense, you are trying to find the limit of a constant, and you know that the limit of a constant is constant.
হ্যাঁ মানে 0 divided by 0 তো 0। হ্যাঁ মিস, ওকে মিস।
No, 0 divided by 0 is not 0. You are getting confused.
মিস মানে 0 divided by anything আর কি, anything
0 divided by non-zero.
হ্যাঁ মিস,
Yes, 0 divided by non-zero is 0. Yes. So 0 divided by non-zero, the x is not 0, so x squared is not 0. So definitely this fraction will give us 0, and limit of a constant is constant. So then I don't need to plug in the limit, plug in the value of x here. Okay. Then we have to, if the numerator wasn't 0, then we had formula, we had trick to apply so that we could find the limits. Okay. But we have 0, a constant. So now we know that limit of a constant is the constant itself. Because constant doesn't depend on the values of x. It doesn't matter what is the value of x, 0 is always 0. Did it make sense to you?
হ্যাঁ মিস, এবার বুঝছি মিস, থ্যাংক ইউ।
Welcome. Now we have to pick another direction so that we don't get the limit 0. We want anything but not 0 to say no. So if you go along the y-axis, the equation of y-axis is x equals to 0. So look at this thing. If x is 0 and y is not 0, then you will again get limit 0. That doesn't help us. But let's take another way. Let's take y equals to x. If we go along the line y equals to x, this is a smooth curve that goes through the origin. So this is one of the direction, one of those infinitely many directions. And if I go along this line through origin, then since xy approaches 0, 0 and y equals to x, I can replace y by x, then I have x comma x approaches 0, 0. That means if x is close to 0, 0, then x is close to 0, 0. That means this, as a consequence, x approaches 0. See if you understand this.
Yes, miss. এবার আমরা অন্য একটা ইকুয়েশন নিচ্ছি।
Yep. Class, are you with me? Good morning.
Yes, miss.
Yes, miss.
Yes, miss.
Yes, miss.
This is not one-to-one class. Please be with us. Okay. Did you understand?
Yes.
Okay, very good. So now we are going to apply this limit and this equation. That means y should be replaced by x and the limit should be replaced by the x approaches 0. So this limit now is x approaches 0. So yx means x times x, yx means x times x square plus y square means x square plus x square. If you do the simplification, notice that we have another constant limit, which is -½ So if you did, because x doesn't equal to 0, class, x does not equal to 0. Since x does not equal to 0, x squared does not equal to 0, and hence x squared by x squared is 1. So we have -½ limit of a constant is constant. So now we have two different directions. Along the x-axis we have limit 0. Along the curve y equals to x we have limit -½ They are not same. That means limit doesn't exist. Exactly. We get to different limits along to different smooth curves, y equals to 0 and y equals to x. Hence, the limit does not exist.
মিস এখন আমরা কিভাবে বুঝবো যে মিস কোন ইকুয়েশন গুলো দিলে ডিফারেন্ট স্লোপ আসবে, সরি ডিফারেন্ট লিমিট আসবে?
It's by practicing. Doesn't matter. Why I mean, after x-axis, do along the y-axis. Definitely you will get the same limit, but that's not enough. That's not enough to say yes. That is the reason I said 10. That is the reason I said 10. Even if you check 1,000 directions and you get the same limit, still you are not allowed to say yes, because 1,000 out of infinitely many is a drop, just a drop. Okay, so it may happen that along other direction you are going to get the same limit, but you still need to keep trying. Take different one. First one was a straight line. If you find same limit, take something curved. Take something curved. Take something trigonometric. Take something in other ways. Okay, just make sure that you get a different limit, and you can do it by you will get it to know by practicing. Practice is very important. Okay, for example, look at the exercise 2. I have given you 5 directions, 5 smooth curves, x-axis, y-axis, y equals to x, y equals to -x, and the parabola. These two will give you the same limit. If you go with the line y equals to x square, remember, if x is close to 0, then x square also close to 0, right? If x is close to 0, then x squared is also close to 0, right?
Yes.
What does it mean? Let me check.
That means x square comma y square is 0, 0. Tends to 0, 0, right?
Come again? I didn't get you.
মিস আমরা তখন লিখতেছিলাম না যে x, y টেন্ডস টু 0 0, এখন মিস আমরা লিখতে পারবো যে x স্কয়ার, y স্কয়ার টেন্ডস টু 0 0।
X square comma y square, no x square comma y square. X is x, y is x square. X is x, x is x. The equation is now y equals to x square. So y equals to x square means replace y by x square. So x comma x square approaches 0 0. And as a consequence, actually x, if this is what you have, then this implies that x approaches 0 and x square also approaches 0, right?
Yes, miss.
Thus, do you follow us?
Yes.
So then, I'm doing this just to show you how to manage this kind of thing. So in place of y, in place of y, you are going to write x square and what should be the limit, you think? You have 3x cubed on top, right? Plus, can you listen to me?
মিস উপরে একটা x থাকবে মিস। ও সরি মিস, নিচে একটা হ্যাঁ মিস, উপরে x স্কয়ার, x টার্মটা থাকবে মিস।
Okay, then you get, what is the denominator then? If you reduce by x square, reduce the fraction by x square, what is the denominator then?
1 plus
1 plus 2
2
Very good.
2x square.
Now I did it for you. What's your name once again? What's your name? The boy I'm talking to. Baba,
Oh,
tumhar
miss.
naam ki?
Miss
Yaron.
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 miss.
Yaron. You remember you mentioned something that when we need to plug in the values in the denominator, we have to make sure we have to change the denominator in a way, of course in a valid way, so that we can plug in the values and denominator is still, the denominator is non-zero. Here you go, denominator is not 0 if you plug in x equals to 0 in the fraction. The numerator is 0, the denominator is 1 plus 0, which is 1, and the limit is 0. Right? This is what you meant, right? That we'll change the fraction so that you can plug in the limits. Since this is not a constant, this is a modified version, this is not a constant. And yeah, now we have the form where we can plug in the values. So yes, now try to plug in the value. So denominator is not 0, denominator is 1, the limit of the fraction is 0. So what I'm trying to see, along the x-axis, along the y-axis, and along the line y equals to x squared, we have the same limit. We have the same limit. But that doesn't mean the limit exists. Okay? That doesn't mean,
2x square হলো না কেন?
for me,
2x square হলো না কেন? 3x divided by 1 plus 2.
what do you, 2x square holo na keno? I didn't understand. Come again.
ও মিস নিচে
Ma'am, in the denominator, 1
3x
plus
to
2.
the power 4.
X to the power 4. Yep.
x to the power 4 এটা না মিস একদম ফাইনাল, 0/1 এর আগে।
Eta.
হ্যাঁ হ্যাঁ।
Oh, I understand. But by mistake, ma? By mistake. That is definitely 2x square, right?
Yes, miss.
Very good now. So class, these 3 will give you the same limit. Let me put them in same color. These 3 will give you the same limit, but that doesn't mean limit exists. That doesn't mean limit exists. Try other 2. Try other 2. They will give you different limit. Okay? So limit does not exist. Limit does not exist. Because look at the function. You are given the same function. The same function. You are given the same function. And the question says that show that the limit does not exist. Okay.
সেটা তো পার্ট এ বি সি ডি করে একদম ফাইনালে করার পরে ফাইনাল অ্যান্সারে লিখবো না যে
No, no.
limits are not
For
null?
no. For exercise 2, you are asked to evaluate limits from those 5 directions. You don't have
Okay.
to. You don't have to comment about the existence of limit here. You just need to find the limits along those 5 directions. That's it. That's the question there. Okay. But question
Yes.
3 says that show that the limit does not exist. That means doesn't matter. You can pick 2 directions from here where you have different limits. You just need to show that limit. You just need to find 2 directions where the limits are different. That's it. And if you need to do 7 or 5 directions or 7 or 10 directions to find 2 where the limits are different, it's completely up to you. Okay? It's completely up to you. Just remember one thing. Whenever you find it, whenever you find that by substitution, you find that the numerator and denominator has same degree, so that you can reduce. For example, you had x square and x square. You had x square and x square. By if x is replaced by y or y is replaced by x, then you will get x square divided by some x squared. Then this choice is the best one. Y equals to 5x, y equals to 6x. You will get something squared over there, you will get something squared over here. The number will be different if m is different. The fraction will be different if m is different. It's a trick, but it's not creative. It's a shortcut. The last thing that I taught you, it's a cheating. This is not creative. Be creative. Did you understand my point?
মানে মিস উপরে আর নিচে যদি সেম ডিগ্রির কোনো অঙ্ক থাকে তাহলে মিস
Yeah.
আমরা y equals to 5x আর y equals to 6x দিয়ে যদি মানে ডিফারেন্ট ভ্যালু আসারই কথা, তাই না?
Definitely. But as I said, this is not creative, no? This is kind of memorizing the trick. So be creative. Okay. So class, now if we want to say yes, or if we want to challenge that we have covered all infinitely many directions, then we have to put a circle around the point and compress the circle and take the radius of the circle close to 0. So for example, let's say that I want to approach this point from any direction possible. I want to approach this point from any direction possible. Then I can draw a circle around that point, and this is the radius of the circle. Make the radius of the circle close to 0. Then the circle will be compressed to the point. Circle will be compressed to this point. That means doesn't matter which direction you are talking. Doesn't matter which direction you are talking about, that direction cannot reach the point without crossing the circle. So since the circle is approaching the point, so definitely infinitely many directions, all of them approaching the point. So this trick confirms that whenever you are using a circle around the point and getting the circle compressed to the point, conversing the radius of the point, radius of the circle close to 0, conversing the radius close to 0, that means that close to 0, I shouldn't say equal to 0, I should say converging means it's a limit concept. If the radius is getting close to 0, that means infinitely many directions are covered. Okay. So here you go. This is a recall of the rule, L'Hopital's rule. We need this. I hope you remember the L'Hopital's rule. L'Hopital rule says that whenever you are trying to find the limits, of this fraction, okay? Whenever you are trying to find these limits, something is not good. If limit of this exists, or if this limit is infinity or negative infinity, then okay. So whenever you are trying to find the limit of this fraction, and when you try to evaluate the limit separately, numerator and denominator separately, if the form of the limit is 0 over 0 or infinity over infinity, If the limit is 0 over 0 or infinity over infinity, class, can you hear me?
Yes,
Yes, ma'am.
Yes, ma'am.
Pin dropped silence. I mean, it's
Miss 0 by
killing me.
infinity হইতে পারে না?
No, 0 over 0 or infinity over infinity. 0 over 0 or infinity over infinity. I repeat. L'Hopitals are applicable only for these two forms, 0 over 0 or infinity over infinity, because they are equivalent, they are similar. You can change one to other. That is the reason this is the only scenario when you can apply L'Hopital's. Then L'Hopital says that limit of a fraction is limit of the fraction of their separate derivatives. Take the derivative of the numerator, take the derivative of the denominator, and if you get the fraction with the derivatives, then limit of the original fraction is the limit of the fraction of their derivatives. Okay, this is the L'Hopital rules. It can be for infinity by infinity or 0 by 0. Same thing, okay? Same statement. Here you go. It doesn't matter, infinity by infinity or 0 by 0. Same, okay? So now look at this thing. If you have 0 times infinity, plus, if you have 0 times infinity, we know that 0 can be written as 1 by infinity, right?
Yes,
Yes,
miss.
miss.
Yes, miss.
Yes, miss.
Oops, sorry. Okay, so we know that 0 can be written as 1 over infinity, so 0 is 1 by infinity, which can be written as infinity over infinity. So 0 times infinity or infinity over infinity, in both cases we can apply 0 times infinity or infinity times 0. In that cases you can write L'Hopital's. Okay, you can apply L'Hopital's, because 0 times infinity can be written as infinity over infinity. Yep.
মিস তাহলে তো 0 বাই ইনফিনিটিতেও তো মিস ইউজ করা যাবে যে 0
No.
টাইমস 1 বাই ইনফিনিটি মানে 0।
No, সম্ভব না, ট্রাই করে দেখো।
ও 0 ইনটু 0 হচ্ছে, হ্যাঁ
Not possible. Okay, guys. So our goal is convert the function to a function of single variable, so that you can apply the concepts that you have learned in section 1.1, 1.2, 1.3, 1.6, and 3.6. If you don't remember those sections, revise them. Otherwise, limits will be difficult to you. Finding limits will be difficult. Shall I continue? Are you ready, guys? Now we want to evaluate. That means we want to learn the trick where we can claim that we are considering infinitely many directions to say yes. Are you ready?
Yes, miss.
Class, are you ready?
Yes, miss.
Yes, miss.
Okay. Look at the question. You have to evaluate this limit. And if you want to evaluate this limit, look at the function. You have function of 2 variables. So by some substitution, try to make it as a function of single variable. By some substitution, try to make it as a function of single variable. So if I just think of this can be considered as a function of 2 variables. That means if I said that z equals to x square plus y square, if I say that z equals to x square plus y square, that is a way to call it a function of single variable. That means in place of x square plus y square, I'm going to write just z. But if I replace this, if I change this and write it as a function of z, I need to change the limit as well. How can I change the limit? Now look at z. The limit value of z is greater or equal to 0. Value of z is greater or equal to 0. If x and y both are close to 0, then their squares are close to 0, and so z must be close to 0. Do you understand that?
Yes, miss.
And z cannot be 0. Z cannot be 0 because z is not 0. Z is positive, because since xy approaches 0, 0, that means at least one of them is non-zero. At least one of them is non-zero. If either x or y is not 0, then this sum of square is positive. So z must be greater than 0. Z must be close to 0 but greater than 0. Do you understand that? Z must be close to 0 but greater than 0. Do you understand that?
মিস গ্রেটার কেন জানি বললেন?
Because x and y both are not 0 at the same time. X and y are not simultaneously 0. This is 0 only, x and y both are 0. But if x is 0, then y is definitely not 0. If y is 0, x is definitely not 0. And it may happen that none of them is 0.
মিস এটা কি স্কয়ার টার্ম বলে গ্রেটার দেন 0 না?
Of course, you are adding a square, so definitely it cannot be negative, right?
Yes, miss.
Class, are you good?
Yes, miss.
Yes, ma'am.
Yes,
Okay
ma'am.
then. Okay then. Now, class, look at the setup. Now we know that we have x squared plus y squared equals to z, where z is a positive number, close to 0 but positive numbers. So since z is positive, square root of z is real. Since z is positive, square root of z is real. So this equation can be written as x squared plus y squared equals to r squared. R is the radius of some circle, center with at the 0, 0 point. That means that equation is used. That equation can be written as the equation can be considered as equation of a circle. And since z approaches 0, 0, so we are taking the circle, we are taking the limit on the radius of the circle, where the circle is where the radius is approaching 0. By this circle, we are covering infinitely many directions. Are you good, guys?
Yes, ma'am.
Very
Yes,
good.
ma'am.
So let's apply the substitution. Let's apply the substitution. So we have this is given. So in place of x squared plus y squared, we are going to write z. And we know that z is close to 0, but z is positive. That means z approaches 0 from right. Do you remember the right limit? Z is close to 0, but z is greater than 0. So z approaches 0 from right. Are you good?
Yes, miss.
So this is the new limit. This is the new limit. This is now calculus 1, and you must know how to find this limit. This has been discussed in chapter 3. Chapter 3 or chapter 1.6? I don't remember. Actually, limits are to infinity, 1.3 or 1.3. But anyways, so since the limit is exponent, since the exponent is negative, you can write it in that manner. Okay? And if you take the limit, just think, guys, calculation should be in your brain. This calculation should be in your brain. If z is 0, class, follow me. If z is 0, 1 by z is infinity, 1 by 0 is infinity. So 1 by z is infinity. E to the power infinity is infinity. 1 by infinity is 0. So this whole thing gives us 0. You don't have to write this. Just ignore this, and you can write this equals to 0. Do you understand that?
Yes, miss.
Yes, miss.
And that should be enough. That should be enough. Are you good? Once again,
Yes, miss.
you are not allowed to write this. Infinity is not a real number. Negative infinity is not a real number. So you are not allowed to write this thing. But yes, if you write it, cross it out. I don't care. Don't let me read it. Okay? Are you good?
Yes, miss.
So let's move on to the next one. This is the next one. Okay, so if you want to evaluate the limits here, there's excuse me, So limit set z equals to square root of x square plus y square, then z is x square plus y square is going to be z square. Z is positive because of same thing, since this is greater or equals to 0, and this cannot be 0, because if this is 0, then x and y both are 0. By the same argument, z is positive. Z is close to 0, z is positive, right? So this can be written in this way. So if you go with this thing, look that this is in 0 over 0. This is 0 over 0. But if you differentiate this, this gets even complicated. Look at the derivative. If you differentiate the numerator, the derivative of the numerator is this, which is even stronger than the fraction you already have. Do you understand that? We know that, class. I need to take a pause and give you more details. Focus. Can you hear me?
Yes, miss.
Yes.
Okay. L'Hopital rules. You have two different scenarios to apply L'Hopital rules. One is 0 over 0. Other one is infinity over infinity. L'Hopital rule should be applied to simplify. It may happen that when you apply L'Hopital rule once, then it gets a bit complicated. Then you should think of applying it twice. And before you apply, you must be careful. If you feel that second application also making it more complicated, then don't go with the fraction immediately. Don't go with the rule immediately. Change the form. Change the form. For example, this is in 0 by 0 form. This is in 0 by 0 form. That means I can apply L'Hopital. Definitely I can apply L'Hopital. But look at the numerator. I have the fraction which is e to the power minus 1 over z is the numerator, and denominator is z itself. So if I apply the L'Hopital, then it will be derivative of the numerator divided by derivative of the denominator. Look at the derivative of the numerator. The derivative of the numerator is this, which is stronger than what we have already. Because derivative of the denominator is 1. But derivative of the numerator is stronger than the whole fraction that we have now. So this is better to change the form. This is better to change the form. So now, since it has a negative exponent, class, did you get me?
Yes, miss.
So since it has a negative power, take it down with a positive power. Take it in the denominator with a positive power. Okay? And then take z up. Take z up. Here you go. That means you are flipping the numerator and the denominator, kind of. Okay? So now you have infinity over infinity form. Now you have infinity over infinity form. Now look at the derivative. This one will not spare us. You get 1 over z squared times e to the power 1 over z. But look at the numerator now. Derivative of the numerator is not 1 now. Over there, derivative of the denominator was 1. But here, derivative of the numerator is minus 1 by z squared. So look at this derivative where you have minus 1 by z squared, and look at the derivative of the numerator, which is minus 1 over z squared. Since z is not equal to 0, 1 over z squared is defined. So you can reduce this by minus 1 over z squared divided by minus 1 over z squared, which is 1. So you have this. Now, if z is 0, 1 over z is infinity, e to the power infinity is infinity, then 1 by infinity is 0. Done. Question, please. Each line has some explanation in red ink. This is not portion of your solution. Just these notes are made to make you understand the scenarios. For example, how I can take 1 over z. This z went up as 1 over z because, see, this is the scenario. That is the reason that we can write it in that way. Class, do you follow me?
Yes,
So
miss.
miss যখন
Yes,
so
miss.
miss
Yeah,
মিস যখন
coming here.
ডিফারেন্সিয়েশন করব হ্যাঁ মিস, যখন ডিফারেন্সিয়েশন করবো মিস যদি লেংদি হয়ে যায় তাহলে মিস ওটাকে নিউমেরেটর থেকে ডেনোমিনেটর নিয়ে যাব, কিংবা ডেনোমিনেটর থেকে নিউমেরেটর নিয়ে যাব, যাতে করে অমিট করা যায় আর কি, তাই না? যতটুকু সিম্পলিফাই করা যায়।
Then try with the different form. If you have 0/0 and it gets complicated, then try with the infinity by infinity. If you have infinity by infinity and it gets complicated, then change it to 0/0. Okay?
Okay, miss.
If both are giving you some complications, then once apply, then change the form. It's a rare scenario, but it is there. It's a rare scenario, it is there. It may happen that 0/0 and infinity both are making it complicated. Then just for the first time, apply the L'Hopital's rule, and for the second time, change the form. Then it gets easier. Okay? I mean, how can we handle L'Hopital rules? That depends how you have learned 3.6, because section 3.6 teaches you L'Hopital's. So if you have studied it well, then yeah, it is good. Then it's an alternative method. This is an alternative method to finish. This is an alternative method to finish exercise 5. Okay. If you are good with this, then don't go for the alternatives. Are you fine?
Yes, ma'am.
Yes, ma'am.
Okay. Whew. For example, this is the one. You have to apply the L'Hopital first, and it gets a bit complicated. Then for the second time, you have to change the form. You must change the form to make it simple. Okay. This is for L'Hopital's 3.6. Okay. Formula from 1.6 class. Formula from 1.6. Sin x divided by x approaches 0 is 1. And there is the other one. This is 1. There are two formulas. There are two formulas. One is this, and other one is
Miss, why is it percentage there?
percentage means just a symbol. Percentage means just a symbol. It's a trick. It's a trick. Whenever you apply this formula, these three things must match. Whatever you have here, that should be the denominator, and the denominator should be inside the sign. Percentage, by the percentage we meant that. Let's say that since percentage is related to numbers, what can I do? I can use a star, right? Star is not a number. Then these three things must be similar. By similar, I mean when these three things are same, then this limit gives you 1. That's it. Okay. And other one is limit x approaches 0, 1 minus cosine x. 1 minus cosine x divided by x. 1 minus cosine x divided by x. This is 0. Okay. All good?
Yes.
Yes, yes.
And if you want to generalize this, in same manner, that means whatever you have here, let me use some other notation. What's that? This one. These, they must be same. Then you get 0. Okay. For example, look at exercise 6. Look at exercise 6. Say if you take this at, say that this is W, or row, doesn't matter. Okay. If this is row equals to this, means row must be positive, row must be close to 0, because x, y, z all are close to 0. Since x, y, z close approaching 0, 0, 0, so row must be positive, but row must be close to 0. And then this thing gives you this. and say rho, not, it's not rho, it's P, 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 P. They are same. And P approaches 0. Doesn't matter from left or right, doesn't matter. P approaches 0. So this is 1. All good?
Yes.
Yes, miss.
And you can apply L'Hopital here as well, because this is 0 over 0. Then you get cosine P divided by 1. And cosine P is close to 0. So cosine 0 is the limit, which is 1. Okay? So class, I have 5, it's already 5:30. Shall I continue? Are you comfortable? I think I should. I think I should, right? How much do I have? I will allow you to digest whatever I taught you today. Let's finish it here. Let's finish it here, because I won't be able to finish limit today, and I don't want to rush, because the next comes the concept where we apply the, so far you have class.
Yes, miss.
Yes, miss.
So far in the exercises, whenever I have substituted something, you had the variable in same pattern. If you had xy, then square root of x squared y squared, square root of x squared y squared. That means when you have same type of equation. You have same type of equation. What if you don't have similar one? What if you don't have similar one? For example, look at this thing. Look at this thing. You have x squared plus y squared. So, and you have y. So if you set x squared plus y squared equals to, if you set x squared plus y squared equals to z, then how you are going to eliminate y by z? So this is a different scenario when you have to change the coordinate from rectangular to polar. Okay, so the last concept of limit is how to find limit using polar coordinates. Okay, and then I will mention the continuity of some functions at that point. Then we will start partial derivatives. Okay, let's finish it here. After when I finish 13.2, after that I will speed up. Okay, after that I will speed up.
Okay, miss.
So please study whatever I taught you today, so that when I speed up, you don't get in trouble. Okay?
Okay, miss.
So do you have question from last lecture?
Miss, if we practice the exercises that you have listed, will that be enough?
If you understand by practicing those exercises, that will be enough. But you must try to understand the concept. Remember, since this is online class, definitely we are not going to give you the same one, because we know that you will have the solution of the same exercises. So we will modify the exercise a bit, so that if you understand the concept, it will be easy for you. Did I make it clear?
Yes, miss.
Okay. Let the azan be finished. The azan is going on from my side. On my side. So. Allahu Akbar. Shall I continue?
Yes, miss.
You have question?
আজানটা শেষ হলে ভালো হতো।
আজান শেষ হয়ে গেছে আমার সাইডেরটা বাবা।
ওকে ম্যাম।
তোমার দিকে কি আজান হচ্ছে?
জি ম্যাম।
Yes, miss.
It will take 10 minutes যদি আমি এর জন্য অপেক্ষা করি।
ম্যাম
আমি
প্রবলেম
continue
আছে
করি।
ম্যাম। হ্যাঁ ম্যাম কন্টিনিউ করেন।
Okay. So class, since we don't have question from last lecture, we know that when we are in 2D, that means the domain is two-dimensional for the function of two variables, then we have infinitely many directions, and to cover each and every direction we have been using the circle, right? We have been using circle and applying limits on circle so that the radius of the circle approaches 0. That means whatever point we try to converge, the point should be at the center. Okay. Now remember, class. Now remember the polar coordinate. Now remember the polar coordinate. If you have a circle, if you have points on the circle, if you denote a point, r theta in polar coordinate, every point on a circle has same r. Theta is different. Do you understand that?
Miss. Distance
So
from
now,
origin is the
since
same.
I need a circle, since I need a circle, and I have that, let's say that we are taking theta from negative infinity to positive infinity. That means it will keep rotating. If I fix r, r will be radius of some circle, and on that circle, if I keep theta open, that means a free variable, then theta will keep revolving around the origin on the circle. That means theta doesn't change the circle. Do you understand that?
Yes, miss.
Plus, do you understand?
Yes, miss.
So when we will be using polar coordinate to find the limit, we will control r, because we know that by definition of polar coordinate, r is given by if x, y is the rectangular coordinate of the point, then r is given by square root of x square plus y square. Since this is the positive square root, r must be non-negative. R is always greater or equals to 0, and r equals to 0 only at the origin. So if I say that r approaches 0, that means I claim that r doesn't equal to 0. That means when we say r is close to 0, we mean all the points on some disk which is around the origin but not the origin. Do you understand that?
Sorry, ma'am, can you repeat this again?
Okay. So I said that, let's say that if r is close to 0, okay, in polar coordinate. Okay, let's say that if x equals to r cosine theta, y equals to r sine theta, and if r approaches 0, then we mean, then by this we shouldn't say we mean, we understand all the set of all points, understand the set of all points on some disk of radius r, or on some points on some small disk, a small disk around the origin but not the origin. That means that set does not contain the origin. Do you understand that? Because r equals to 0 at the origin, but we have taken only r which are close to 0 but not equal to 0. So we are taking all the points which are really close to the origin and around the origin, because see, we did not try to control theta. So theta can be any real number from negative infinity to positive infinity. Okay, do you understand that? For example, if I mean, let's say that I'm going to prepare the XY plane with two axes, X and Y axis. Class, can you hear me loud and clear?
Yes, ma'am.
Yes, miss.
Yes, miss.
Okay, let's say that this is our X and Y axis. Okay, I'll make it small. I'll make it small. Okay, say that this is, oops, the vertical line is not that good. I'm not happy with that, but I'm not getting it better. We understand this is the y-axis, okay?
Yes.
This is the y-axis, so this should be the x-axis. So if I take a circle around the origin, see if we take a circle around the origin, so see, I am not trying to control theta. I am not trying to control theta. That means since theta is not controlled, so when I say that theta is, let me keep it like that. When I say that theta is 0, okay? When I say that theta is 0, this is where we are. Then, sorry, let me fix it. Okay, so then theta is open means theta can be anything from negative infinity to positive infinity. When theta keeps increasing or keeps decreasing, increasing means it keeps rotating like that, but on the circle. Decreasing means it keeps rotating like this, but on the circle. Do you understand that? It doesn't change the circle. We need minimum theta, minimum range of theta, we need a full rotation from 0 to 2 pi. But in this definition, theta is any real number. In this definition, theta is any real number, but I left theta open. Theta doesn't change anything. The direction, let's say that if I talk about some direction now, I have to get out of the equation, sorry. If I talk about some, কিছু বলছিলে? Question?
Miss, decreasing হলে কি anti-clockwise ঘুরবে?
Definitely, because angle is positive in the anti-clockwise direction, and
Miss,
angle is negative. Increasing means I said increasing means anti-clockwise. Decreasing means clockwise.
Okay, miss. Thank you.
Didn't I say increasing anti-clockwise?
Yes, miss.
This anti-clockwise positive now? Anti-clockwise positive now?
Yes. So it gets bigger when it moves anti-clockwise, right?
Yes, miss.
Okay, so now what I'm trying to say, since I'm not trying to control theta, it doesn't matter what the theta is. For a fixed theta, if I make a larger circle, let me make it larger. Okay, let me fix it on the right place. Where is it? Yep. Okay, so let's say that this is our circle, huh? So if we have theta fixed, let's say that this is theta. What is the theta? If this is the theta, then you are talking about this direction. If this is the theta, then you are talking about this direction. We just need to cover infinitely many directions. So what we mean, we leave theta open as a free variable so that theta can be any real number to cover infinitely many directions. We just control R. Because we know that doesn't matter what theta is. R is fixed for this circle. If I get smaller circles, then R is getting closer to 0 and theta doesn't change. If we just go along this line, for example, along this line, theta is fixed, R is changing. So along some direction, if it is a straight line, theta is fixed. If it is along some ray, theta is fixed, right? So we are not trying to control theta, we will just control R. Okay, did you understand that when you use the polar coordinate?
Yes, miss.
Now the next thing that you must understand is that when we will be using this concept, when you are using Z to substitute, and when we definitely need polar coordinates. So let's start with the one which can be done by both methods. For example, for this one, This one, you can do it by setting z equals to x squared plus y squared or r equals to square root of x squared plus y squared. Doesn't matter. Do you get me?
Yes, yes. Miss,
Why?
আটটা মানে polarity টা আমরা
Yeah,
করি, তাই না?
r means the polar coordinate in r means the coordinate in polar coordinates. Yep, that's the first coordinate in the polar coordinates. Both method works because you can use z, because look at the equations. If you see the variable equation, variable factor, they are given in same pattern. They are given by the same equation, x squared plus y squared, x squared plus y squared. So it doesn't matter you want to set z equals to x squared plus y squared or you want to set r equals to square root of x squared plus y squared. Doesn't matter. Okay, both will give you the same thing, same limit. But
I have a question.
Sure.
Is z the equivalent of r squared?
This implies if you say r is squared, then r is squared means x squared plus y squared. Just square this, both square this. Oops, sorry. If you have this equation, if you want to mean r is squared is the square of this. This is not equivalent, but you can evaluate r is squared from there. This is r is squared then.
No, ma'am, because z equals x squared plus y squared. So
Yes, z is r squared. The z is over there, r squared. Yep.
all right. Thank you, ma'am.
Welcome. And the question is, why are we able to set z or r equals to this? We can set this as z or this as r squared because the equations are given in same manner. So we can substitute z, then you will get a function of single variable. Okay, there will be no theta. Okay, but of course, if you write it r squared, there will be no theta. It's independent of theta. But look at the next one. For example, exercise 7. This is homework. You must complete exercise 6. Okay, doesn't matter you set z equals to x squared plus y squared or you set r squared equals to x squared plus y squared. Doesn't matter, limit will be same. But for exercise 7, look at exercise 7. You have two different type of variable equations. One is x squared plus y squared, other one is just y. So you won't be able to set z equals to y or z equals to x squared plus y squared. Suppose that if you wish to set z as x squared plus y squared, then how are you going to eliminate y? Because you have to keep everything with a single variable. Logically a single variable. For example, when we have theta, we said that theta is free. We don't try to control theta. That means we have to control a single variable r. So over here, you don't have chance to set z equals to y or z equals to x squared plus y squared to make this function as a function of single variable. Because even if you try to set this as z, and if you solve for y is going to be square root of plus minus square. Of course, we don't know y positive or negative. So y is going to be plus minus square root of z minus x square. But in the solution of y, you have x and z, two variables. That means you are not able to write it as a single variable. Do you see the problem?
Miss, can you give an example? মানে আগের কেসে কি হয়েছিল যে y যখন আমরা in terms of y যখন আমরা লিখতেছিলাম তখন মিস এখানে শুধু x থাকতো, তাই না? মানে দুইটা ভেরিয়েবল থাকতো না, আর এখানে মিস মাল্টিপল ভেরিয়েবল থেকে যাচ্ছে, ওইজন্য আমরা করতে পারবো।
That's it. You are in different type of exercise. তুমি যেটা নিয়ে কথা বলছো, that one was the first exercise that we have done. For those exercises when you replaced y by some equation of x, that was for some particular direction, along some particular curve. Now I'm comparing with the evaluation. When you compare with the whole, when you consider the whole of it, that means we consider from infinitely many directions. Last two exercises. For example, this one. For example, this one, you set z equals to x square plus y square. Z equals to square root of x square plus y square. Then this is z, this is z. That means you don't get any other variable term. You don't get the whole of this can be written as a function of z. Okay, same for the other one. Same for the other one, exercise 4. Where is exercise 4? Should be here. Here is exercise 4. Same for this one. See, if z is x square plus y square, then this function can be written as e to the power minus 1 over z. You have a single variable function. Okay, even for number 6, which one I have given you to work at home. So look at number 6. Look at number 6. If you set z equals to x square plus y square, then you have z times the natural log of z cubed. That means 3z times natural log of z. So this is a function of single variable. But how can you write it as a function of single variable with this? If you set z equals to either y or z equals to x square plus y square, isn't it tough now?
Yes, miss. আমার কাছে যেটা মনে হয় তাহলে আগের সবগুলো কেসে একটা কমন ফ্যাক্টর ছিল, তাই না? যে মানে হ্যাঁ মিস, কমন ফ্যাক্টর ছিল না, যে ফর এক্সাম্পল মিস যে আমি যে এর আগের অঙ্কটাতেই x স্কয়ার প্লাস y স্কয়ার যদি z ধরতাম তাহলে এটা হইতো z ln z কিউব।
Same, by common factor you mean a same equation, right?
Yes, miss.
Yeah, that's true. That's true. But when you have different type of equations, for example, this is the equation which is just y, and this is the equation which is x square plus y square. Since we have different equations in different pattern, now z substitution will not work. Now we have to go with the polar coordinate, with the concept that we will take the circle, we will fix r, and we'll let theta vary. We'll let theta vary. We'll not try to control theta. Is that good?
Yes.
Okay then. So let's start. So we know that you don't have to, if you remember this, you don't have to go with this. You can just say that r equals to this. Okay. But since you have to replace y, so y equals to r sine theta, you have to know this, right? So let's do with all details. So we know that if I want to write it in polar coordinates, using polar coordinates, set x equals to r cosine theta, y equals to r sine theta, and these two equations, combining these two equations, we get r equals to this, which implies that r square equals to x square plus y square. If you don't want to, you need to write r, because we have to get the limit for r. So r equals to square root of x square plus y square, which implies that r square is x square plus y square. And now look at r. R is denoted, class, can you hear me loud and clear?
Yes, miss.
Yes, miss.
Yes, miss.
R is given by a positive square root. Since r is given by a positive square root, r cannot be negative. R can be close to 0 or equal to 0. But since xy is close to 0, 0, that means xy is not the origin, so xy are not simultaneously 0. That means one of them is non-zero. One of these two terms is positive. That means r cannot be 0. R is close to 0 but positive. R is close to 0 but positive. Do you understand this?
Yes, miss.
মিস লাস্ট দিন এটা মনে দেখাচ্ছিলেন না মিস, যে xy যদি 0 0 তে যায় তাহলে মিস both are not simultaneously 0, তার মানে একটা greater than 0, ওই জন্য r greater than 0.
R greater than 0, but since both variables are close to 0, so r should be close to 0. Now let's substitute this. So from this, now we have a single variable which is r that we need to control. Y is r sine theta, and x square plus y square is r square. So now we are ready. Now since we set theta as free variable, so we are just focusing on the function of r, a single variable r. So now we are in calculus 1. So since theta is not our concern, so sine theta can be considered as a constant. Sine theta can be considered as a constant, and over here you can write as r to the power 6, where 6 gets down as the coefficient.
Exponent.
So you have, exponent becomes the coefficient for the log function. So we have 6 times r, which is this r, sine theta natural log of r. So we have constant which is 6, which is independent factor, independent of
6
r.
sin theta.
6 sine theta. Take them out. Take them out. Then you have this. So now, according to, I don't like this. Okay, here we go. So now, if you focus on this limit, you have r which is close to 0. You have natural log of r where r approaches 0 from right. I don't know if you remember this graph. If you remember this graph, this is the graph of the natural log function. Natural log function, though this is not very clear because over there it seems that the blue curve is touching the y-axis, which is not true. Y-axis is the vertical asymptote. Y-axis is the vertical asymptote. So the graph will never ever touch y-axis. The graph will never ever touch or cross y-axis. So it will get really close to the y-axis, but it will never touch it or cross it. Y-axis is the vertical asymptote. Of the function, the graph or of the function. Okay. So now what we see that if x is really close to 0, definitely positive because x must be in the domain. X must be in the domain, and the domain of natural logs is set of positive numbers. But there are infinitely many numbers which are close to 0, which are definitely positive numbers but close to 0. So if x is close to 0, then y gets really close to the y-axis. That means it goes straight downward. The curve goes straight downward and closer to the y-axis. That means straight down means near negative infinity. When x is close to 0, y is close to negative infinity since it's going down. So this is the observation of the graph. If x is close to 0, of course from right, because x must be positive, then y, which is natural log, it's close to negative infinity. The other tail says that, the other portion, other end of the graph says that if x is close to positive infinity, it will jump towards positive infinity. That means if x is close to positive infinity, then y is close to positive infinity. So from there you get two limits. So now, right now we are using this one. Right now we are using this one. If the input is close to 0, look at the function. We know that r cannot be negative. We know that r cannot be negative, and since r approaches 0, definitely r is not 0 as well. R is a positive number. So if the input r is close to 0, then natural log of r is close to negative infinity. Ignore the negative for the time being. Ignore the negative for the time being. Why we can ignore the negative? Because we know that when you are evaluating the limit of a function, which is a constant type of a function, constant times a function, then you can take out the constant and find the limit of the function. If you think of negative infinity is -1 times infinity. When you are talking about approximation, you get infinity, which is not a real number. But if you have a number which is close to infinity, and if you multiply that number by -1, then you get some number which is close to negative infinity. Okay, so from that understanding, 0 times negative infinity can be considered as 0 times infinity. দেখো বোঝো কিনা?
Miss 0 times infinity কেন আসলো জানেন মিস? মানে ইনফিনিটি বুঝছি মিস, যে আপনি যে বললেন যে যখন r 0 এর খুব কাছাকাছি থাকবে তখন ln r হবে ইনফিনিটি.
If you apply this limit on r, what is the limit? It's 0, right? If you apply the limit on r, it's 0. R is close to 0. Done. So this is 0. If you apply the limit on this, then this is negative infinity. So you have 0 times negative infinity. But we ignore the negative one. Is that good now? So now the question.
Why can't we consider ln 0?
Ln 0 is undefined.
Oh.
And r is never 0. R is never 0. R is positive over there, right? R is positive. So why should I consider 0? R is close to 0, but not 0.
তো মিস নেগেটিভ ইনফিনিটি আমরা যে নেগেটিভটা নিচ্ছি না, এটা কোনো সমস্যা হবে না মিস?
No, it is there. It stays there. It's not that we just drop it somewhere. No, it is there, blended in the equation. So it will come in. Here is that negative appears somewhere there. So don't bother about that negative. So the pattern is it's 0 times infinity. So now we can make it infinity over infinity or 0 over 0. We can easily change it to the form either 0 over 0 or infinity over infinity. I have shown you this thing before. Remember over there? So 0 times infinity. Wait a minute, not that one. Wait a minute, not that one. Where is it?
It is equivalent to 0 by 0 form, right?
Here you go. 0 by 0 or infinity by infinity form. Either one. Either one. So you can decide which one should be taken. You can decide which one you want to take. Okay? So now the question is, don't forget this remark. It is always difficult. Class, do not forget this remark. It is always difficult if you flip natural log. You have to flip it twice to keep the equality. If you have to flip it twice to keep the equality. If you say that natural log equal to, then you flip once, then second time. First time once and then twice. That means denominator is this one. This blue portion is the denominator, which can be written in this manner. Look at the denominator. It is really complicated. The derivative of the denominator will get complicated if you flip the natural log. Look at the function, which is natural log of r to the power -1. When you have a function with negative power, it gets stronger taking derivatives. With successive derivatives, it gets stronger. So you should not flip natural log. Now infinity comes from the natural log. So you should not try to flip infinity. You should flip 0. That means if you want to flip r, then flip it twice. 1 over 1 over. 1 over 1 over r. This is equal to r. So let's continue then. Let's continue then.
মিস এই জায়গাটা বুঝি নাই মিস, আপনি যেটা বললেন যে আমরা এক্সপ্রেশনটা যেভাবে আছে ওভাবে রেখে দিব, তাই না? লন আর এর ক্ষেত্রে ওটাকে আমরা ফ্লিপ করব না, কিন্তু আর কে জাস্ট ফ্লিপ করব।
You have to flip one of them to get either 0 over 0 or infinity over infinity. You have to flip at least one of them. So which one should you flip? I said no, I didn't say constant. I said don't flip the log. I said flip the other one. There is no constant. You have a r, which is not a constant, definitely not a constant. You have natural log of r. That's also not constant. Those are functions of r. Okay?
Yes, miss. কারণ আমরা তো ডিফারেন্সিয়েশন অফ লন আর জানি যে ওটা তো লন আরই হবে, isn't it? মানে
1 over r.
Yes, 1 over r.
So by flipping you get this. Now this is in infinity over infinity form, so apply the L'Hopital's. So if you apply L'Hopital, take the derivative of the numerator, which is 1 over r, take the derivative of the denominator, which is -1 over r squared. So this is after the L'Hopital. After applying the L'Hopital, you are there. If you do the simplification, then you have negative r. So if r approaches 0, you take the limit, plug in the approximation, which is 0, then the limit is 0. Do you understand that?
Yes, miss. Miss, আমাদের কি পরীক্ষায় ফিগার আঁকতে হবে?
No, you don't have to. Don't have to sketch the figure, but yes, you must know the graphical limits. That concept is discussed in 1.6, where you understood the graphical limits. Because when you use a graph to find the limits, that method is, that concept is called graphical limits, and you must know how to find the graphical limits of log function, not natural log. Natural log is a very particular case. I'm talking about any log. Do you have question on number 7, class?
মিস আমরা এখানে যে লিমিটটা বের করলাম, মিস এখানে তো আমাদের মাল্টিপল ভেরিয়েবল ছিল, তাই না? আর মিস আমরা যে 120 তে লিমিট করছি ওইটা তখন জাস্ট একটা ভেরিয়েবল ছিল, isn't it?
Yep. That is the reason using concept and coordinates, you convert it into a function of single variable. Because when you are here, when you are here and you set theta free, then you have a function of single variable, because from here you continue with the concept of calculus 1, math 120. The same concept. Just keep sine theta out of this. Okay? That's it. From that line, you have concept of calculus 1. What about other students? Do you have question?
No, miss. No, miss.
So we 4 are in class today. So I can
No,
take
miss.
attendance of 3 students then.
ma'am.
Are you sure?
Yes, miss.
Yes, ma'am.
I should give 22 attendance to Aaron, because he is the one who is in responsive mode. Other are in sleeping mode, so you should get 0 attendance today. Shall I?
No, miss. Math tech
No,
very
miss.
tough লাগছে তাই।
It's not easy. I said that before. It won't be easy, but if you don't try to understand, if you don't ask questions, then all the confusions will be there, and it will be even more difficult to you to understand. Right?
Yes, miss.
Participate. Ask questions. Clear your doubts. Make it easy for you. So shall I continue, or you have questions on this exercise?
Yes, miss, you can continue.
Class, what about other students?
Yes, miss. Continue.
Yes, miss.
Okay then. Finally, I'm done with 13.2. Because look at exercise number 8. You can do it by setting z equals to x square plus y square, or r equals to square root of x square plus y square. It doesn't matter which method you are going to apply. So I'm not going to do number 8, because
It's অন্য একটা করে।
definitely I'm going to do number 9, and you will do number 11 for me. Okay, you may choose 9 or 11. Which one is yours?
নাইন করি।
মিস, তাহলে আমরা যে সাবস্টিটিউশন করতেছি যে x ইকুয়ালস টু r cos থিটা, y ইকুয়ালস টু r sin থিটা, মিস এখানে তো ট্রিগোনোমেট্রি কিছু আসতেছেই না, রাইট? মানে মিস আমরা যে সাবস্টিটিউশনটা করতেছি।
Yep, because whatever trigonometric functions appears in the substitution, we consider them as constant. We don't try to control them. Okay?
Yes.
Do I have to discuss this? Look at the numerator. The numerator is a plus b times a minus b, when the denominator is a plus b. Do you see that?
Yes,
If the
miss.
denominator is a plus b, then the numerator is going to be a plus b times a minus b. So you can reduce a plus b from numerator and denominator, then you will be left with x square minus 4y square. And in place of x square minus 4y square, if you plug in the approximation 0 for x and 0 for y, then you get 0. The limit is 0. Is that good to everyone?
Yes, miss.
Yes.
So limit is 0. So do I have to do?
11 নাম্বারটা করে দিন।
Okay, no harm. Let me copy paste from above. Where did I write all this note? Here you go. Same 2 lines for whenever you apply polar coordinates. There you go. Let me write the word solution. Then we get this. So now, oops, sorry. Now class. So if I start with this, So if I start with this, let me write it down. What I get in the place of limit, I have r approaches 0 from right, and over here what I have, x is r cosine theta. So x square means r square cosine square theta. Are you good, class?
Yes, miss.
Yes, miss.
And y is r sine theta, so I can just write y, which is r sine theta. And then I have natural log, and inside the natural log I have r square. All good?
Yes,
Yes,
miss.
Okay then. So then, let's continue. I don't like this test, you know. So now, if I simplify this, so cosine squared theta and sine theta can be taken out.
R cube.
Wait a minute, I didn't copy it properly. So let me copy it again. Okay, there you go. The cosine squared theta and sine theta, there you go. There you go. And then we have r
Miss, এখান
cube.
থেকে r টা যাবে না sin theta r
No,
সামনে
yeah, ওটা আমি erase করব. This one, yeah. And then over
4r
there we have,
cube
over there you have r to the power 4. Okay. So in the next line,
4 টা তো
let's
বের
take
করে
that
দেওয়া
4 out. Okay. So now we have, and I don't think I have to explain all these things. This is in zero
yes.
times
Miss,
zero
ওই
form,
আগেরটার
so
মতো।
we have to, exactly. So 0 times 0 form e thakbe, so I will take it to infinity form. Do I have to continue then, or you will
No,
be
miss,
able
we
to
have
No,
to
continue?
flip R.
Process the same.
You yeah, exactly this in same manner. You don't flip this one, you flip r cubed. Okay. You don't flip natural log, you don't flip log, any log, you don't flip log, you flip r. So let's take in the denominator. So in the denominator, when you are in the denominator, so you have to have 1 over r cubed. Since you have to flip twice, so here you go. Then continue. This is in infinity by infinity form, so apply L'Hopital. I will just leave it with that note. Rest is on you, okay? Oof. Text is in dancing mode. Here you go. There you go. And if you ask me the limit, the final answer, there you go. This is the final answer. Okay. And at the end of the class, you are going to submit exercise number 9. But I will continue now. Okay, by the way, I will copy and paste and create a new exercise. I will copy and paste to create a new exercise. Okay, there you go. Give me something else. Give me anything that comes to your mind. See what can you bring it on.
Ln root over x square plus y square.
That's a simple one. Okay, since you mentioned it, I will take it.
Oh, পাওয়ারটা হাফ হয়ে যাচ্ছে।
Powerটা half হয়ে যাচ্ছে, exactly. But this is you have this in your book. You have this in your book, a similar one. Is it number 12, right? Okay. Anything else? Anything else? R cubed. R cubed. So we need to take it this is in 0 times infinity form. Okay, over here you have 0 times infinity form. This is in 0 times infinity form. Let me put the dot to mean times. Okay, so 0 times infinity, where is it? 0 times infinity form. So this is in 0 times infinity form. So if you want to write it in 0 by 0 or infinity by infinity, in place of it, then you either write 0 equals to 1 by infinity, either you write 0 equals to 1 by infinity, or infinity equals to 1 by 0 to get it in 0 by 0 or infinity by infinity form. So I recommend you not to flip infinity, because infinity is coming from the natural logs, and you should not try to flip log. Because if you flip a log function and then you don't flip just once, you flip twice to keep the equality. To keep the equality, you flip twice, and if you do twice flipping the thing, then the log goes as a fraction, as reciprocal in the denominator, and it's impossible to vanish that one or simplify that one after that. It gets even stronger with each successive derivatives. So what you do, you just flip r cubed. You flip r cubed. You take r cubed in the denominator. So that means, but you have r cubed. You are given this. So you have to keep it equal, because you are given r cubed. So what you have to do, you have to take it in the denominator.
1 by r.
Exactly. You have to flip it twice, because if you flip once, then this is not equal. If you flip it once, then this is not equal. But if you flip it twice, just you do it with the তোমার হাতের পাতা দিয়ে করো। If you use your palm, the palm of your hand, then do it twice. You will see the same face of the palm. You understand that?
Yes, ma'am.
So that's the concept, nothing else. Okay.
Maybe একটু উপরের দিকে একটু স্ক্রল করেন তো।
Sure. Which portion? আর উপরে?
না ঠিক আছে ম্যাম, ঠিক আছে।
Please, number 12 টা কি আমাদের class work?
No. Number 12, I'm going to edit, because 12 and this is just homework. Okay. This is just homework. Number 11 and number 12 almost same, so I'm not going to let you work on that. But yeah, miss, I have a different one for you. Yep.
মিস আপনার এই যে ওয়ার্ড ফাইলটা, এটা তো মিস যেটা আগে দিয়ে দিবেন তাই না মিস ক্লাসে, মানে আমাদের গুগল ক্লাসরুমে?
After each section, if there is a decent modification, then I give you the modified one as well. So after finishing 13.2 today, I will give you the updated one. You have updated 13.1. Follow the revised one.
Check করুন, thank you.
Do you have question, class? Shall I continue?
Yes, yes.
যে বাবা বলছিল উপরে দেখাতে, did you get the confusion cleared?
জি ম্যাম, clear.
Okay. So now I'm making the copy of this one, because I want to make a note on that thing. So let's say that over here you have just xy. Let's say that you have xy inside the natural log. Now how to manage it? How can I separate them?
ln a plus ln b এই ফর্মুলা দুইবার হবে।
So what do you get here?
x square y ln x plus x square ln y.
X square y ln
x.
No, you didn't get my point. You didn't get my point. By substitution.
ln x plus ln y.
No, ln x plus ln y.
মিস তাহলে আমরা এটা নিব হচ্ছে z equals to x plus y.
You didn't get my point. After substitution, you do it after substitution. Because if you do it before substitution, that doesn't help you. If you do it before substitution, that doesn't help you. You have to do it after substitution. So that if you do so, I'm going to write it in short form. From there, you are going to get cosine square theta. Cosine square theta.
R square sin theta cos theta হয় মিস
Sin
ln
theta.
xy
Sorry.
ln xy কে কি r square cos theta sin theta লেখা যাবে?
Exactly. Ln xy ke likhbo. First, you have to write it. First, you have to write it in polar coordinates. Then you
আর
can
কিউব কই থেকে
separate.
আসলো?
What do you mean by r cube koi theke ashlo? Did you write x square?
ও হ্যাঁ হ্যাঁ মিস সরি হ্যাঁ
X square means r square cosine square. Y means r sine. So you
Sorry,
have r
miss,
square times r cube. No, you don't need to be sorry, but yeah, you do. You have this thing, right? So then you have sine square, r square, sine theta, cosine theta, right? Do you understand this?
হ্যাঁ মিস আমরা এখানে 2 আনতে হবে মিস সামনে।
After that, forget about two. After that, because right this moment you cannot take down 2, because this is not a whole square to take down 2. Okay. After that, you are going to apply the formula that I mentioned there. Okay. So here you go. Plus this. So what does it mean now? So now you have this and this. Do you see that? Do you understand this? Take this as A. This is A. I will make it red. Okay. And this is B. This is B. I will make it blue. So if you have a natural log of A times B, then you have natural log of A plus natural log of B plus. Do you follow me?
মিস তাহলে কি ln sin থিটা cos থিটা এখন একটা ইয়ে হয়ে যাবে না, কনস্ট্যান্ট হয়ে যাবে, রাইট? এখানে তো কোনো আর নাই।
Exactly.
তাহলে সামনে চলে আসবে।
Yep.
তাহলে তুমি এই 0 হচ্ছে না, আর কিউব থাকতেছে শুধু।
Let me show you. Then over there this comes out. Okay. Class, do you follow me?
Yes, miss.
Yes,
Yes,
miss.
miss.
Yes, miss.
Comes out, then manage it. I don't think that it will be difficult for you to take care, right? And over here you have just r cube. I will erase r cube in the middle. Oh, okay, don't worry. Just take this out. Erase this thing. Okay, and then you have to find the limit of this. So here you go. The limit of this is 0. The limit of this is 0, and you have seen that this is also going to give you 0. So here, the limit will be, eventually the limit is 0. So complete. Not now.
মিস বাম সাইডে তো 0 হবে, ডান সাইডে তো 0 হবে।
সেকেন্ড লাস্ট লাইনটা থেকে লাস্ট লাইনে কেমন আসলো?
Last line from second last line. I didn't do anything only. I kept theta independent of r. So
মিস
this
এই যে ln sin theta cos theta এই
Yep.
লাইনের পরে cos square sin theta এই জায়গাটার মধ্যে ln r square আসলো কিভাবে?
ln r square means
কই ln r স্কয়ার তো নাই।
এই যে মিস
ও
আপনি
আচ্ছা।
হ্যাঁ
এটা-
এখানে
এটা
মিস এই যে এটার পাশেরটা
পাশেরটা এটা
লেফট সাইডের এক্সপ্রেশনটা মিস।
হ্যাঁ লেফট সাইডে এই
What
যে
is-
এটা
ln r স্কয়ার।
এটা
what is
নিচে এটা নিচেরটা
I'm coming
Immediate.
there. I am coming there. What is the problem from getting from here to there? What don't you understand? Which portion you don't
ও
understand?
না আই এম সরি মিস দুইটা তো প্লাস একসাথে না আমি ভেবেছি কি যে আপনি এইটার থেকে একটা করে ফেলছেন না
No. Plus sign is there.
ইয়েস মিস এখন বুঝেছি সরি মিস সরি
No. It's okay. Don't need to be sorry. Class, are you comfortable now?
ইয়েস মিস।
Yes,
Yes, miss.
Miss.
দুটোই 0 হবে না?
Duto is 0. Yep. So the final answer is 0. Hamza, do you follow us?
Yes, ma'am.
Do you have question?
No, ma'am.
Okay. So now if you go with the definition of continuous function, a function is said to be continuous at a point AB if the value of the function equals the limit. If the value of the function equals the limit, then the function is continuous. Okay, and if the function is continuous at every point of its domain, then we say that the function is continuous function, or we say that function is continuous everywhere. If the function is continuous on its domain, we say that function is continuous everywhere. If the function is continuous at some point, then we mention it. Okay. So if you have a
13.2 এর পরে
no, this is portion of 13.2. This is portion I didn't explain much here because after I teach you partial derivatives, then I will get back to continuity with a couple of exercises, but not now. Okay, not now. Just for now, remember the definition of continuous function. Continuous function is a function where a function is continuous at some point if the limit of the function at that point and the value of the function are equal, then the function is continuous. And the property of continuous functions, if two functions are continuous, then their composition, their sum, their difference, their product are continuous. If the quotient is continuous on the set where the denominator is not zero. Quotient is continuous on the set where the denominator is not zero. Let me change this because I think I had given you a similar one. Why don't you make it 5? Because the domain is all real numbers. Domain is all real numbers, but if I want to make it not x, y square. Okay, now the domain is where x doesn't equal to plus minus y. X doesn't equal to plus minus y. That means y equals to x, y equals to minus x. Except those two lines, the domain is the whole xy plane. Okay, so if I say that this 1 negative 1 is not in the domain. 1 negative 1 is not in the domain because 1 negative 1 is on the line y equals to negative x. Okay, so then try to evaluate this. This should be number 13.
মিস আগেরটার সাথে এটা কি বললেন মিস বুঝি না এটা
I said that I need to edit that exercise because I have already given a similar one. Class, you are not reading previous exercises. You are not following the lecture. Look at this thing. This is a similar one. This is a similar one. When the point is in the domain and the limit is just the value. Since we are talking about continuity, this function is continuous at the point 1, negative 2. Because 1 negative, this is a rational function, 1 negative 2 is in the domain of the rational function, and the rational function is continuous on its domain. So if I want to evaluate this 3 times y times x is, what is x? X is 1. Then we have this divided by x square, which is 1 square, plus 2y square, which is negative 2 square. Exactly, this is the domain. Excuse me. Excuse me. So that the domain is negative 6 divided by what we get from the denominator? 4 times
9.
Means this is negative 2 by 3. So this is the limit. This is the limit. Look at the exercise. This is the I repeat. This is the rational function. The rational function is continuous on its domain, and the domain of the function is the whole xy plane. The whole xy plane, and this is a member in the xy plane. So this should be in the domain of this function, and since this is a continuous function, so the limit should be the function value. So just evaluate the value. That's the limit. Done. But I wanted to change that one. I wanted to say that the function is not continuous at the given point. Now look at the function. This is a rational function. It must be continuous on its domain, and its domain is domain of this function. If you want to make, wait a minute.
All real numbers.
Yeah, no, not all real numbers. The domain of this function is, let me
xy plane. all
No,
values.
not the whole xy plane. Not the whole xy plane. Look at the denominator. Denominator can be 0 as well. X comma y, that means the members from the xy plane such that x squared doesn't equal to y squared. X squared doesn't equal to y squared. That is x doesn't equal to plus minus y. When you take square root, you include plus minus on one side, not both sides. So when you take the square root, so x does not equal to plus minus y. So that's the domain. So x doesn't equal to negative y, or y doesn't equal to negative x. So 1, negative 1 is not in the domain of this function. Now it's up to you how you're going to manage it. Okay?
তাহলে মিস
Now,
কন্টিনিউয়াস না, এই পয়েন্টে কন্টিনিউয়াস না।
definitely the function is not continuous at 1, negative 1, because function is undefined at 1, negative 1. Undefinedness, how can you say that limit will equal to something that is undefined, right? So definitely function is not continuous at 1, negative 1. But the other one we just did, number 4, the function is continuous at 1, negative 2. Okay?
Limited value by.
Yep. So that's it for 30. That's it from 13.2 for now, and we'll get back to continuity after I teach you partial derivatives. I'm not sure if I have that important notes over here, but I have a very good exercise to mean that relation between existence of partial derivative and existence and being continuous. Before you had exercises where you know that continuity does not guarantee the differentiability, but differentiability guarantees continuity. If a function is differentiable, then the function is definitely continuous for function of single variable. I repeat, if a function is differentiable, then the function is definitely continuous. But if the partial derivatives of a function exist, then not necessarily the function is continuous at that point. If the partial derivatives exist at some point, then the function is not necessarily continuous at that point. And this is a very good understanding, a very good observation. And I will get back to the topic continuity of a function with this exercise, with that kind of exercise at the end, by the end of section 13.3. Okay, so 13.2 is done. Question?
No, miss.
No, miss.
I said something many times. What did I say? After 13.2, I'm going to do what? By the way?
Miss, partial derivative.
Yeah, after 13.2, I'm going to start 13.3. This is obvious. I am definitely not asking that. Exactly. I will pace up a bit, not a bit. I will really pace up. That means I will go in faster pace. So please, class, you have a weekend. You have a good weekend because it's Wednesday. I'm going to meet you on Monday. So you have a weekend. Please, just wrap up 13.1 and 2 so that you are ready to cop up the pace. Okay? Because after that, I'm going to finish every day a new section. And you have to revise that. You have to get them organized, and you have to prepare good notes before you come back to next class. Okay? I'm going to take your attendance. That's it for today. But, don't let me forget. By the time I take your attendance, could you please submit this exercise, the number 9? Please, submit it.
Miss Kunta?
Number 9, in red. You see the red one?
Miss, এখন করব?
Yep. 10 minutes. It's 5:31, so you have to submit by 5:41. Okay, Hamza?
Yes, ma'am.
How do you feel? Will it be okay for you to submit?
Yes.
Okay, go for it. I'm giving much time since it's a new exercise for us. So please submit it by 5:45. Okay, 5:45. So enough time, more than enough. And by that time, I'm going to take your attendance. So class, day 6, section 17. Please type a Y if you hear your name. So I'm going to start. Rifat Hussain, Tanshen, Abrar Karim. Mehdi Hassan, BMM Bari, Sadaf Islam. Mehdi Hassan, Sadaf Islam. Mehdi Hassan, Sadaf Islam. Mehdi Hassan Shohel, your attendance is very low.
ম্যাম আমার একটা ক্লাস মিস হয়েছে ম্যাম। গতকালকে ক্লাসটা ম্যাম তাও হচ্ছে ম্যাম আমি ক্লাস করছিলাম, আমার লাস্টের দিকে কারেন্ট চলে গেছে ম্যাম, পরে আমি অ্যাটেন্ডেন্স দিতে পারিনি, শুরুতে ছিলাম।
You didn't write me, so I'm not going to consider that. Sorry, Baba. You have if that kind of thing happens to you, write me immediately so that I can keep a note. Okay, but definitely not after. Yep. Definitely not after 48 hours. I'm not going to take that then. Okay?
আচ্ছা ম্যাম আমার তো একটা ক্লাস মিস হয়েছে শুধু। এখন ম্যাম আমি যদি নেক্সট ম্যাম আমাদের তো ম্যাম অ্যাটেন্ডেন্সে একটা পয়েন্ট আছে ম্যাম, আপনি ম্যাম ওখানে তো লেখা ছিল যে আমি যে সবগুলো ক্লাস করবে তার একটা বোনাস পয়েন্টও থাকবে ম্যাম।
Yep. You don't have the bonus point. You already missed one.
না আমি তো ইচ্ছাকৃত করি না ম্যাম, এখন আমি যদি নেক্সট ক্লাসগুলো সব করি এবং পারফরমেন্স যদি ভালো থাকে ম্যাম, এই ক্ষেত্রে কনসিডার করবেন?
I don't know. Let's see how it ends. Okay, you just give your 100%.
Okay, ma'am.
Okay. If I see my student trying, I see. I don't distinguish. Unfortunately, many students they don't try, but even I try for them. But if students try, then I try to give more than 100%. Okay.
Ma'am, that will be enough, ma'am. Thank you, ma'am.
Sadaf Islam not present. Shahriyar Hassan, Mohammad Safti. Mohammad Safti is not there. Yaron, Hamza, Mohammad Nawaz. Hamza, Mohammad Nawaz. Are you there, Mohammad Nawaz? Okay, Mohammad Nawaz is not there. Oh, I saw you. I'm sorry. I can see you. Sakib Reza, Noor Kalam, Naza Naila. Very good. Abid Hassan, Abu Jafar, Sadman. Abid Hassan, are you there? Okay, I didn't get you, Abid Hassan. Ehtasham, Tamim,
yes,
Shuraiya.
I did.
You what? Ehtasham or Warrior?
Miss Abid Hassan.
Abid Hassan, I didn't see your attendance. You have to type a Y, right? It's it's your.
I did.
You did when,
Yeah.
Baba? You did when? I don't see your name. Did you type Y?
Miss, it's yes, miss, I did. It's the email Kazim Mumita Mustari.
Okay. Yep. We talked about that. I forgot. I have 140 students, and it's difficult for me to remember this kind of thing. It's not that. I mean, we have students with different names in many classes. Okay, Abid, I take your
No, yeah,
attendance.
this is weird anyway.
Okay. When you write, you just if I keep calling you, please just give me a reminder, please. Thank you. So Ehtasham is there. Abu Jafar, I saw Abu Jafar. Ehtasham is there. Tamim, I didn't get you. Tamim, not present. Tamim bin Mahabub, not present. Tamima, Nusrat, Kaji Osman. Nusrat or Kaji Osman, wonderful. Rafia, Hasibur, Ratul.
Miss Tamima পেয়েছেন?
Yep.
Thank you.
Ratul, are you there? Ratul?
ম্যাম রাতুল আপনাকে একটু জানাইতে বলছিল ওর বাবার কি করোনা আক্রান্ত হয়েছে প্লাস আইসিইউতে অ্যাডমিটেড গতকাল তাকে দুপুরবেলা ভর্তি করাইছে
Up to now his attendance is 100%. আল্লাহ দোয়া করি আল্লাহ সবার বিপদ থেকে বাঁচা বাবা মা অসুস্থ থাকলে খুব কষ্টের সেটা Sabir Hussain, Fayaz Faisal. আমরা যা কিছু শিখছি রাতুলকে একটু পৌঁছে দিও না, ওকে একটু আপডেট রেখো। এই সময় পড়াশোনা তো সম্ভব না, বাট সবকিছু ম্যাটেরিয়াল তার কন্ট্রোলে থাকলে বা তার সাপোর্ট থাকলে ইট উইল বি ইজিয়ার, এ বিট ইজিয়ার। সো সাব্বির পেয়েছি, ফয়সাল পেয়েছি, ফায়াজ পাইনি। ফায়াজ, আর ইউ দেয়ার? Fayaz Ibn Habib, not there. Okay. Afsana, Nabiul, Farzana Rahman, are you there? Shukti?
Yes, ma'am. I'm here.
You have to type a Y to say yes. Okay. So,
yes, ma'am. I was taking the picture.
You're taking a picture? Okay. I didn't get Fayaz. I didn't get Fayaz Ibn Habib. I didn't get Tamim bin Mahabub, Muhammad Safti, Muhammad Sadaf Islam, and Rifat Hussain. Rest is good. Thank you so much. And that's all for today. You have another 6 minutes to submit.